Alright, so first off, congratulations. You have made it through Math 3. We're now going to start reviewing everything you need to know for your final exam. The first day, we're going to talk about all the algebra topics that you need to know. Then tomorrow, you're going to talk about all the different geometric topics that you need to know. And then you'll spend the last few days working on a final review packet that'll help you get ready for that test. So first off, you need to know all about polynomials. You should be able to add, subtract, multiply, and divide them. This is something that you have done since Math 1, but some of you still might have some questions, so we're going to go over this really quickly. So first, if I were to add 3x squared minus 4 plus 2x plus 5x minus 6x squared plus 7, all you would do is combine like terms. My x squares go together to give me negative 3x squared. My x's go together to give me 7x. And my numbers, my constant terms, go together to give me a positive 3. Remember, our answers are always written in descending order by powers of x's, so that means that the x squared goes first. If I were to change the sign in the middle just to a subtraction sign, that means I would just subtract like terms, or you can distribute the negative. It is up to you. I choose just to subtract them. 3 minus negative 6 is a positive 9x squared. 2 minus 5x is a negative 3x. And then negative 4 minus 7 would be minus 11. And again, answers in descending order. Be very careful because remember your state exam is multiple choice, so these answers could look very similar to each other with one little detail changed. Next, to multiply, say 2x squared minus 6x plus 1 times x plus 3, you have a couple different options. One, you can box it, which is, remember, you draw a box, divide it out, so x3, 2x squared, negative 6x, and a 1. Multiply like old school math, so 2x to the third, negative 6x squared, x, 6x squared, negative 18x, and 3. Like terms, always on the diagonal, so my answer is 2x to the third. 6 and negative 6 cancel, minus 17x plus 3. Another way to do this is to basically just distribute, which is what you are doing in this box, but some people have trouble with the box. Distributing means you're going to do 2x squared times x minus 6x times x plus 1 times x. Then you distribute the 2x squared times the 3, the minus 6x times 3, and the 1 times the 3. All this gives me is what is in my box. Next, division. You have 2x squared minus 13x, or 2x to the third, excuse me, minus 13x squared plus 26x minus 24 divided by x minus 4. Remember, we talked about two different methods that you can use to divide. One of those being long division, the other being synthetic. I'm going to refresh your memory, hopefully on both. The first one, long division, we write x minus 4 outside our house. 2x to the third minus 13x squared plus 26x minus 24 goes under the house. And then you say, what times x would give me 2x to the third? That would be 2x squared. Multiply this term to both, so I get 2x to the third minus 8x squared. We change the sign of both so that these cancel. Negative 13 plus 8 is negative 5x squared. Bring down my other terms. Then you do the same thing again. This time it would be negative 5x would give me negative 5x squared when multiplied to x. So that would be negative 5x squared plus 20x when distributed to both terms. You change the sign of both, so the first two cancel, and leaves me with 6x minus 24. Then one more time, x and a 6x is 6, so I'll multiply by 6. That gives me 6x minus 24. Change the sign of both, they both cancel, so I do not have a remainder. That means this is my answer, and x minus 4 is a factor. If I were to do this with synthetic division, remember the rules for synthetic division are: first, we're dividing by a linear term, so x minus 4 is linear. There's no power bigger than 1. And we need a coefficient of 1 in front of x. If there's a coefficient here, we must divide every term by our divisor, and up here by that number. In this case, we don't have to do that because x is just x. With synthetic division, remember you draw your kind of upside down house. Your opposite of your divisor goes in the box, so 4. You write out all your coefficients. If a term is missing, replace it with a 0. Leave a little space, bring the number down. We multiply, add, multiply, add, multiply, add. The last number being our remainder. These are my new coefficients of my answer. And if you notice, they match what we found before. Either one of these is acceptable for you to do. Next, we have what's called a rational function, and this was a chapter that you all love to hate. Rational functions are things where like y equals 2x minus 1 over x plus 2. You need to be comfortable finding vertical asymptotes, holes, horizontal asymptotes, and solving these. Also being able to graph them. But again, it's multiple choice, so all you need to be able to do is identify them. So we're going to go through these 5 things. If you remember, a vertical asymptote is a line that goes up and down that the graph cannot touch. Vertical asymptotes are where the denominator equals 0. A hole is any term that cancels out. So in this case, I have no holes, so this one has no holes because nothing cancels, and a vertical asymptote of x equals negative 2. Our horizontal asymptotes, we have 3 cases, and it's all based off the degree. In this case, my degree is 1 in the top and 1 in the bottom, so I have a horizontal asymptote of y equals 2. If you remember, those rules for horizontal asymptotes, case 1, degrees are equal, then y equals the ratio of the coefficients, of the leading coefficients to be exact, because remember you can have a bunch of coefficients, which is our case here with 2x minus 1 and x plus 2. Case number 2 is if the numerator is bigger than the denominator. That would be something like x squared plus 1 over x minus 4. Here, anytime I plug in a number for x, the top will always be bigger than the bottom. So that means that no horizontal asymptote exists. It will never flatline. It's called an oblique asymptote. Case number 3 is if the numerator is smaller than the denominator, or if we just flip these two. So x minus 4 over x squared plus 1. Here, no matter what we plug in for x, the bottom will always be bigger, creating a smaller and smaller fraction. So in that case, y will be 0. So there are your three cases. Y equals the ratio of the leading coefficients, it doesn't exist, or 0. So next, you should be able to graph this. The key to graphing at this point, because in pre-cal you're going to talk about it a whole lot more, is to straight plug it in the calculator. Now, you have to be careful. This problem up here, x minus 4 over x squared plus 1, if you type that into y equals just like that, you will get the wrong answer. You will get something that looks like this. So in my calculator, if let's see if I can make that glare go away. Doesn't look like it. Can I make the glare go away? There we go. Y equals x minus 4 divided by x squared plus 1. Look at that graph. Does that look like anything we graphed before? No. What are we missing? Hopefully you realize that this needs to be in parentheses so that it says the whole entire thing of x minus 4 is being divided by x squared plus 1. So if I go in and fix that aspect and then hit my graph, it's very similar to what we've done before. This one's just a little v. If we do the original problem, which was 2x minus 1 over x plus 2, you might see even more familiar of a graph. And again, all you have to be able to do is identify the correct one on a multiple choice exam. Please do not miss these easy peasy problems. Lastly, you need to be able to solve these. And by solve, I mean something like this. X over x minus 1 equals x minus 2. Remember, our whole goal in this is to get x by itself, and one way to do that is to find a common denominator. My common denominator, this is over 1, is going to be every factor. So my common denominator is 2 times x minus 1. I am not using that 1 because it doesn't matter. It doesn't change anything when you multiply by 1. What I do is I look at my old denominator and see how it changed. It changed by multiplying by 2, so I need to multiply this by 2. Yes, I know, those cancel. That's the point. I'm not changing the problem, I'm manipulating it. This problem completely changed, so I need to add the 2 and the x minus 1. Here, I only changed it by x minus 1, so I'm going to plug that in. Because my denominators are all the same, they don't matter anymore. Then I'm going to just clean up and solve this problem. 2x minus 2x plus 2, because you're just minusing this, kind of distributing a negative, equals x squared minus x. These cancel. I have x squared minus x minus 2 is 0 when I get everything to one side. That factors into x minus 2. X plus 1 is 0. So x can be 2 or negative 1. I double check my answers. If I plug in 2 here, I'm good. 2 minus 1 is 1. Negative 1 minus 1 is negative 2. So that's okay. My denominator will not be 0. So both of these answers work. The idea is you're looking for things that are not extraneous. What would make this extraneous is that vertical asymptote of 1. So if you were to work out this problem and got x equals 1, it is not a proper answer. It is extraneous.